Okay, in this video, pre-calculus, we are looking at oblique triangle applications and area. So we won't get all of that done in this video because I don't want it to go on forever. Anyway, so we've learned about the law of sine and the law of cosine. So why do we need them? Well, we need them for triangles, of course, that are not right triangles. That's why we are calling them oblique triangles, just like we did in when we were talking about law of sine and cosine. I don't know why I'm tripping over my words. Yeah, well, it's whatever. Okay, so let's look at this first example. Due to winds, a tree grew so that it was leaning 4 degrees from vertical, so you get this 94-degree angle right here. At a point 35 meters from the tree, the angle of elevation right here is to the top of the tree is 23 degrees. What is the height of the tree? So we are looking for the height, and you can tell right away this is not a right triangle because this angle right here is 94. So of course we need to find the height. Well, if you'll notice, I can use the law of sines. I can use a height over the, oh, I did that wrong. Sorry, you can use height over the sine of the angle opposite it, which is 23 degrees. And if we had this angle right here, we could use 35 over the sine of that angle. Well, if you'll notice in this triangle, we have 23 degrees and 94. So I can just use my triangle sum theorem that tells me that all triangles are equal to 180 degrees once they add up all the angles. So if we subtract this, we get an angle of 63 degrees. So that's that angle right there. So that's what I'm going to use in my formula. So now I'm just going to cross multiply. And now I'm going to divide by the sine of 63. Easy peasy, lemon squeezy. And now we will get approximately, and of course, we will just put this into our calculator. Just make sure you close those parentheses right there. And what you end up getting is approximately 15.3 meters tall for the tree. Groovy. All right, so this video is really short, so I'm going to go ahead and look at my next example, which is also an application problem for an oblique triangle, but this one's a little trickier because I don't give you the picture. So sometimes drawing the picture is actually more challenging than doing the work. So let's spend some time on this. We have a plane that flies 400 kilometers at a bearing of 310. So this is going to involve our information about bearings that we learned in a previous video. So we're flying at a bearing of 310 degrees from Dallas to Amarillo. The plane then flies 710 kilometers to Roswell, New Mexico, which for our purposes here will be due west of Dallas. I believe it's pretty close. And we are going to find the bearing of the flight from Amarillo to Roswell. Okay, so let's take this one step at a time. The very first thing we're going to want to do is draw a picture. So the first thing I recognize is that the plane is flying 400 kilometers at a bearing of 310 degrees from Dallas to Amarillo. Well, let's say Amarillo is right up here, and let's say Dallas is somewhere in this direction, which it is. Okay, so I am going to just draw an XY coordinate plane here because I have a bearing of 310 degrees. So this is a true bearing right here. It's not a directional bearing. So we are starting north right here, and we are moving clockwise 310 degrees, which would be roughly right there. So I am going to draw that out there. So there's my 310. So I'm going to let this right here be D for Dallas. And then we're going towards Amarillo, and that is 400 kilometers. Okay, so that's how we get this stuff drawn. All right, now we are looking at the plane flying 710 kilometers to Roswell, which is due west of Dallas. So I'm going to say Roswell is right here. Okay, so that would be due west of Dallas, and that is at 710 kilometers. Not a great triangle for Miss Griggs, but it's cool. So find the bearing of the flight from Amarillo to Roswell. So what we're looking for here is we're looking for the bearing from Amarillo to Roswell. So what we are going to need is we are going to need this angle right here. Because think about this, if we write it as a true bearing like this, we're going to need to know from here all the way around to here. So that is why this is a little bit of a challenging problem. But if we draw some lines in here and work through this, it won't be too terrible. Okay, I promise. So the first thing we need to recognize here is that we know this angle right here. Okay, we know what that angle is, because if this is 310 degrees, then we know that 1, 2, 3 quadrants is 270. So if I go up to 310, that means I've gone up another 40 degrees. So I know that this angle is 40 degrees right here. And that means that I have a situation that allows me to find angle R right here. We can't find this angle up here yet because we don't have this distance. So what I'm going to do is set up the law of sines. So using 400 kilometers over the sine of angle R, that's at Roswell. And I'm going to set this equal to 710 because it's across from the angle I know at 40 degrees. And that's going to be over the sine of 40 degrees. And of course, I'm going to cross multiply as always. Well, not always, but in this situation. Then I'm going to divide by 710. And then in your calculator, we're looking for the angle R. So we're going to type in sine inverse of 400 times the sine of 40 divided by 710. And what we end up getting for R is approximately 21 degrees. We're going to round it to a whole degree. So I now know that this angle is 21 degrees. Why is that helpful? Well, because if we know this angle and we know this angle right here, then we can determine what this whole angle is, and that will help us. All right, so this angle, I've got 180 minus 21 plus 40, which ends up giving me 119 degrees. So this angle is 119 degrees. But I need to figure out some other parts to it so I can figure out what this bearing is. Okay, so here's what I need to do next. I'm going to use, let me erase a little bit of this so we can see it better. All right, so I'm going to switch colors here. I'm going to use a little bit darker color, and I'm going to draw in my XY axis, because that will help me. I want you to recognize that this and this are parallel to each other. That means that this angle is equal to this angle right here. See, we're going to piece this together. Step by step is how we're trying to figure this out. Okay, well, if this angle is 40, then this angle has to be 50 because that's a right angle. So that means that this angle is 50 degrees, and if I subtract that from 119, I get 69 degrees for that angle. Excellent. All right, so if I go ahead, I can go ahead and find my bearing. Watch this. This is north, this is south, this is east, and this is west. So I could write that the bearing from Amarillo to Roswell is south 69 degrees west. Okay, that's the directional bearing. And you would be done there. You don't have to go on. But if you want to write it as a true bearing, okay, you can barely see that. So a true bearing, you want to start here, north, and you want to go all the way around here. So if you want to do it that way, you just have to remember that this 40-degree angle would be 40 here. And we know this is 90 degrees. So the true bearing would be 90 plus 40 plus 50 plus 69. So you could write the bearing as 249 degrees. See, easy peasy lemon squeezy.